looking pretty good there, and I believe it's right at noon, or 1 o'clock your time, Mark, according to the
Yes.
computer. So let me take this opportunity to welcome all of you out there that have joined us. We appreciate your interest and participation in our webinar series. I'm Steve Larson from Hoard's Dairyman magazine, and with us, of course, today is Mark Thomas and our co-host Mike Hutchins. And today's webinar, Group Handling and Feeding of Calves, a very hot topic these days, and it is presented today in association with the Dairy Calf and Heifer Association, an organization of dairymen and growers of young stock for us in the industry. So again, welcome to all of you, and Mark, we're glad to have you here, and we'll turn it back to Mike to introduce Dr. Thomas and get us going.
Well, very good, Steve. Welcome, Dr. Mark Thomas. We are excited to have you on our program here today. And this is our third year of webinars. Mark grew up on a beef farm in New York State, got his Bachelor of Science degree at Cornell University, and then followed up with his DVM at that same school as well. He then graduated also in 2001 from the Penn State Dairy Production Medicine Certificate Program, and then he is in partnership with some other co-workers at Countryside Veterinary Clinics, which is up in northern New York State, and they serve about 200 dairy clients as far as that goes. Mark also does some teaching at the Cornell Pro Dairy Program and the Summer Dairy Institute at Cornell University at this point. He also co-founded a group partnership in a group called the Dairy Health and Management Services, which provides decision-making consultation to dairy clients throughout the United States and internationally. And of course, since he has nothing else to do, he's very active at AABP. In fact, he's a District 1 Director of AABP. That is the National Bovine Group as well. So Mark, we welcome you to our Hoard's Dairyman webinar, and I'll turn it over to you. Have a good one.
Great. Thank you, Mike. It's a pleasure to be here this afternoon with everyone, and thanks for taking some time on a busy Monday to tune in and listen to this presentation. So today I have a number of goals, but I'd like to share with you the benefits of optimal nutrition and growth for our young milk-fed calves, and hopefully if you don't already embrace the philosophy of feeding calves for accelerated growth, you'll come around to that thinking. I'd like to spend some time on the practical systems that are available for ad-lib feeding and show you the process of acidification and how we can bring that into implementation for these ad-lib systems. I'd like to then go through some research summaries, some work that we've done to share some of our experiences, and then also looking at some of the practical aspects of feeding acidified milk. And we'll wrap up with a summary. So just to get started here to see what people are doing in the audience is what quantity of milk do you currently feed to a 4-week-old calf? So 2 quarts, 3 quarts, 4, or are you already feeding ad-lib and you're just tuning in today to get some more information?
Well, Mark, the polls are open, and we're often voting at this point, so hang in there. It looks like we have a lot of Republicans online because they're voting early at this point, and often. And often, that's right, Steve. That's good. No, those are Chicago voters. Those are Chicago.
Oh, that's right. I forget.
Yep, exactly right. So we've got about we're kind of stuck on 41% now. We'll give them about a total of about 45 seconds, and then we're going to close this. So hurry up and vote, you crooks out there. Let's go. Let's go. And
okay, we could also maybe say if you're not yourself feeding calves, if you're a consultant, you can either give your own viewpoint. What should people be feeding, or perhaps the majority of your clients, customers, how are they feeding calves?
Right.
Okay, well, we're closed here, and Mark, I'll read the results to you here. As far as 2 quarts, we had 14% had 2 quarts, 2 liters. Another 14% had 3 quarts, 3 liters. 54% said 4 quarts, and 17% all they want, ad-lib. So kind of a mixed bag here. Any comments?
Great. So it looks like that the majority here are feeding either 4 quarts a day, so a gallon a day, or less. So we'll certainly talk about that, and hopefully some questions will arise from that discussion. So let's move right on to what are the benefits of feeding calves for optimal growth and performance. So there are a number of studies that have been done over the years to show these benefits. And I'd like to point out here that there's going to be some times in this presentation that I'm going to give you some opinion. Okay, this is Mark's opinion. And then throughout most of the presentation, I'm going to give you information that's research, okay, from either peer-reviewed research that's in the Journal of Dairy Science or other journals, and also some research that we've conducted ourselves. Okay. So first off, we know that the immune response of both Holstein and Jersey calves can be dependent on the pre-weaning and post-weaning performance. And that was shown by Ballou from Texas A&M, from Texas Tech, when feeding various planes of milk replacer. And they looked at immune function at a cellular level. There's also some work that shows that the source of trace minerals and the plane of nutrition can help support a healthy immune system. Okay, so just giving you some more information to show that we know if we feed calves well that we can affect at a cellular level the white blood cells that function and prevent disease. We can affect those directly. A study that was done at Cornell University by Terry Olivet and Daryl Needham was quite instrumental in showing the effect of nutritional plane on performance of calves that were infected with crypto experimentally. Okay, and the next slide here shows that these are calves that were fed either a high plane of nutrition, the HPN, or conventional nutrition. And if you want to put this in perspective, we can say that the conventional nutrition is what those of you feeding 4 quarts or less a day are, and the high plane of nutrition would be below Ad-lib. These calves weren't fed Ad-lib, but they were fed for a higher rate of gain. And you can see that in all cases here, the calves over the first about 4 or 5 days did lose weight, but you can see that weight loss was less in the high plane versus the conventional plane of nutrition. What's interesting is these calves were then challenged experimentally with crypto. They were fed cryptosporidium eggs, and they all got sick. But you can see here the average daily gain. So these calves were all infected with crypto, and they all got disease. But the calves that were fed the high plane of nutrition, okay, had a greater average daily gain, as you can see from this graph. And they also had a decreased severity of the disease and recovered more quickly. So based on this study, we see that calves that were treated equally in terms of the experimental infection, but one group was fed for higher plane of nutrition, they were able to overcome the disease, they were less affected by that disease insult, and had a higher average daily gain in feed efficiency as compared to those calves that were fed for more conventional feeding rates. Okay, so one question that often comes up is based on some work many years ago, is that growing calves too rapidly may negatively impact or affect future milk production. So how many of you out there feel that this is the case? If we grow these calves too fast, they gain weight, they increase in size too rapidly, that may actually be negative. Those of you who don't think so, and those of you who question, well, gee, I'm not really sure, what should I do?
Well, the polls are open. Mark, again, we're off and running here, and now we're up to 46%, so the Democrats must be coming on board right now.
Voting quick today.
But we're moving along. But true false, it's a little easier question to answer when it's pretty much black or white at this point. So we're getting close to 40 seconds here and almost got 2/3 of the vote
60%, yeah.
Okay. So it looks like the overwhelming majority of participants here today feel that we can grow calves more quickly than we have in the past or at an accelerated rate, and we're not going to have a negative effect on future milk production. And well, you are correct in that this is the reason, one of the reasons why we're doing this. So what about future milk production? So there are a number of studies I'd like to go over, and then I'll summarize a bunch of these. But at Miner Institute, not too far from where I am here in northern New York, they fed calves 1 1/4 versus 2.2 pounds of milk replacer powder per day. Okay, and then they followed these animals through their first lactation and found that the cows which were fed for the higher rate of gain as calves produced a little over 1,500 pounds of milk more than their counterparts of first lactation. And studies like these obviously take a while to do because we're feeding calves today, and then we have to wait till those animals get pregnant, freshen, complete a lactation. So we don't get these results overnight, but thankfully there have been a number of groups, Miner Institute and Cornell University, which have followed animals through this. So one of the most kind of instrumental research projects that were undertaken was by Mike VanAmburgh at Cornell University. And Mike can really be recognized as the person who helped change the industry standards of how much we feed calves. Because really prior to a lot of Mike's work, early calf nutrition came in a bag. You had a cup and you filled it to a certain line or to the top with milk replacer, and that's how much you fed. So in 1998, Mike VanAmburgh started feeding calves for 2 pounds of average daily gain during the milk fed period. And what is very different in a number of Mike's studies, and then followed these calves through nutritionally through the entire rearing period, is that he didn't just feed for increased energy, but matched the rations so that we were feeding for lean tissue growth. Okay, so we weren't just making these heifers fat, we were depositing muscle, depositing protein also. And many of the earlier studies didn't do that. They gained, these heifers gained weight quickly, but their weight was disproportional with an increased amount of fat deposition. So this work, there's over 1,000 weaning weights, and they were able to carry through 725 animals to first lactation. And they were looking to see if there was any relationship between calf performance and first lactation performance. As you can see, there was quite a range in average daily gain, so from a ½ pound to 2.67 pounds, so likely some calves that succumbed to respiratory disease or scours or other issues. But the bottom line is that milk yield increased by 900 pounds in the first lactation for every 1 pound of gain above a ½ pound a day. So if we can improve average daily gain by 1 pound, so we're up around that 2 pound a gain, then we're going to have somewhere in the neighborhood of 1,500 plus pounds of first lactation milk. Here is a summary of a number of additional studies that have been accomplished, and this is just looking at data that analyzed calves at weaning that doubled their birth weight with liquid feeding. Okay, so we can attempt to mimic some of these average daily gains by getting calves on starter very quickly, and we can have a discussion as to the efficiency of that. But remember that these are young milk-fed calves that their bodies are designed for growth and performance under milk, not solid feed. And you can see through these studies, including the Cornell study, that on average there was 840 kilograms. Okay, so again, similar to that 1,600 pound first lactation number, but 840 kilogram first lactation benefit if we can double birth weight at weaning, and doing that with liquid feed. Okay. So the summary of these nutritional effects is that we know that nutrient intake early in life can have a significant impact on future lactation performance. And if you think about that, that's real important, because what we do, we know colostrum can also have an effect, but milk feeding also. And what this shows is that what we do really early on in that animal's life has a long-term significant effect on lifetime performance. I think that's really important to point out. Okay, what we do early on, the first few hours of life with colostrum, and then the first weeks of life with milk feeding can have a significant impact on the lifetime production of that animal. It's also important to realize that all the data that has looked at this has either been positive or neutral. So there hasn't been any negative effects found. So those of you, about 9% of the audience, voted true, that can have some detriment. Good question for discussion later as to what data have you seen, or what are your concerns with that, because so far all the data that we have is either positive or neutral. The mechanisms that are underlie this process are not really understood, okay, but obviously there's some genetics there, but some other setting of the machinery in place for future performance and milk production. So the bottom line is that there is future milk in early life, and we need to capture that, okay, so through nutrition. So how do we accomplish that? Okay. So another question, and maybe I gave it away a little bit here, but as long as we feed for a high plane of nutrition, colostrum feeding at birth is less important. So do you think we can overcome some of those issues related to colostrum feeding if we just feed well post-birth?
Okay, the polls are open again, and we've got lots of voting early on here. We're up to 40% in 17 seconds, Steve. So, and
yeah.
Mark, we're motoring right along here as far as that goes.
Yeah, about half of them, over half, 50% voted.
It looks like a
moving
runaway.
towards 60%, so great.
Great. So it looks like the overwhelming number in the audience feel that this is false, that colostrum is important. And yes, that is true. As I said, there are a number of studies that look at just the performance of animals in their first and second lactation by antibody levels or amount of colostrum fed. But we also know that disease can have a significant effect on future performance, and that colostrum, as you all know and have heard many times, is the key, one of the keys to preventing disease in early life. So we need to continue to pay attention to colostrum feeding. It's still an area, despite years of us preaching, that we still have room for improvement. So get that colostrum in, because that also has an impact on future performance. So now let's move on and talk about the options for group housing facilities and how we incorporate group housing and ad-lib feeding together. So some of this is a little bit of a picture show. I'll show you some new designs, the brand new barns that have been designed and built just for this purpose. Plenty of remodeled facilities out there. Again, we're in the dairy industry. There's lots of older facilities, and sometimes this is a good move. Other times, as you know, we should start from scratch, but oftentimes economics don't allow that. And especially this time of year in New York, Wisconsin, wherever you may be, we can capitalize on some outdoor rearing. And in the more temperate climates, potentially year-round. So what are some of the challenges we face? Obviously, with everything we do, there's pros and cons and opportunities and challenges. And I'll say that having been part of working with herds who have done this for about 10 years, ventilation is going to be our stumbling block. Okay, and when we start to group house animals and put them in a common environment, what's often said is we're going to increase the risk of respiratory disease. I don't believe we actually increase the risk necessarily, but it will depend on the facilities that we have and the availability of good ventilation. You can see here in this slide we have some of the positive pressure ventilation tubes that Ken Nordland from Wisconsin has, I'll say, reinvented, because there were many of these in facilities over the years, but the problem with them is that they were sized inappropriately. Someone just put up a tube and stuck a fan on the end of it and didn't really do any of the engineering or physics related to airflow. So we didn't know how much airflow we were getting. So these work well in both new facilities and retrofits when we remodel. So key is number of air exchanges per hour, and that's going to obviously vary depending on the time of year, but work with your consultants and other individuals to get ventilation right, whether it's a new barn or an existing facility. Secondly is the surface for the calf and the bedding. I'm going to lean towards a non-concrete surface with really good drainage. I think you can attain drainage in concrete with concrete flooring to some extent, but what works really nice is a natural surface, either sand, gravel, that allows for complete drainage. And obviously there's some challenges to that also, but those can easily be worked through with some proper design. Plenty of dry bedding. These calves that are group housed are more than likely fed at a higher rate of nutrition or ad-lib fed. And what does that mean? It means that there's more manure and there's more urine. They're eating more. So think about dry cow manure versus lactating cow manure. We're at a higher plane of nutrition, so we're going to have more moisture in the environment. So good amount of bedding, especially in the winter months where we can allow these calves to nestle and be a bit protected from any cold. The next point is space availability, and this is also critical. When we abuse the space requirement, that's when we start having issues. So we're going to want to see about 30 square feet per calf, if not more, of lying space. Okay, so that's area that the calves can lie in comfortably. And we also want to look at the number of calves in that pen. There are some producers that can handle large numbers of calves, I'll say 25, 30 calves per pen or more successfully. Again, each of these areas affects the other. So with really good ventilation, dry bedding, plenty of space, then maybe we can get to those higher stocking densities. But a good goal is to try to fill a pen in about a week. So that's going to really vary depending on your herd size, and maybe you need to fill a few pens a week if that's a real large herd, but keeping that age range within check also. And then there's a whole host of different feeding systems that we can implement. Ad-lib feeding of milk is fairly new to North America, within about the past 10 years or so, and we have lots of producers, dairymen, that are pretty ingenious and have developed all different types of systems, from the most basic to quite sophisticated. So I'll show you a few of those to give you some ideas. Okay, so how do we deliver ad-lib milk to calves in these type situations? So I'll go over the gang feeders. There's also the automated or computerized feeders, robots, what some people call them, give us lots of information. And then I'll show you quite a number of systems of ad-lib acidified feeding, again with some basic and then some more sophisticated mechanical systems. Okay. So gang feeders, these are the New Zealand style gang feeders that are quite common in certain areas. They're real inexpensive, just a bucket with a bunch of nipples. Potential hygiene issues, okay, now not always, but depends if these are being clean. Are we feeding acidified milk in these systems, or are we just feeding straight milk? Okay, and then I asked the question, is it ad-lib? If we can keep this vessel filled throughout the day so that calves can come back and drink whenever they want, then that will be an ad-lib system. If there are 5 nipples and 5 calves in a pen, obviously one calf may be a bit more dominant and drink more. And certainly if we don't have enough nipples for all the calves and they're just given a finite amount of milk, then we may not have an ad-lib system. So these can work, but it depends on the volume offered. Is it available throughout the day? The automatic feeders will provide a host of information and data. They're computerized, so we can set these to deliver milk, whole milk, or milk replacer, or a combination of both, depending on the age of the calf. Again, we have lots of data. We can see how many times the calf visited the feeder, how much they consumed. So some real-time early information if we have a calf that's maybe sick and not eating as much. Some have the ability to weigh the calf on a weigh platform when they enter the stall. Certainly this is a greater investment than some of the systems I'll show you. And individually this is going to be where people need to decide what they're looking for in terms of data, ease of the mechanization of this, and then how many calves you're feeding also, depending on the size of your farm. Obviously, these are going to require a bit more maintenance. So we have solenoid valves and so forth, and mixing. So that's something to be taken into consideration. And I'll point out that these are not always ad-lib systems. So the companies that design these systems have really done a lot to improve the availability for feeding to multiple nipples at one time. But because of the expense of these units, what I find is oftentimes we have too many calves on a single system. We're trying to maximize the number of calves per unit or per nipple. And that also, because we have computer control over this, we think we know better than Mother Nature, and we assign how much a calf should drink, maximum amounts. So I'll argue, if you have one of these systems or you're considering them, just turn it on ad-lib. Let calves drink as much as they can. And I'll just challenge all of you, in what other neonate species, in what other young animal species do we limit feed milk? Whether it be obviously a beef cow or a foal on a mare, that they're ad-lib. Human babies, we often are feeding those babies until they're satisfied. We're not limit feeding. So why do we limit feed calves? Why do we think we know better and not allow them to drink until they're satisfied, drink for their nutritional and metabolic needs? So allow these feeders to offer as much milk as these calves want to drink. This slide just shows an example of such here, and you can see can everyone see my pointer? That's available.
You can see it. Yep,
this feeder is designed. Okay, great. This feeder is designed to only offer, and again, there's been some changes to some of these, but this feeder can only meter milk to one nipple at a time. So these are two separate pens. So if a calf comes in, this calf, say, is drinking, and this calf comes in and has either is younger, so is prioritized, or has been greater time between feedings, it will turn off milk to the one nipple and provide milk to the other calf. So again, this is where we need to pay attention to settings and the availability of these feeders to feed multiple calves at one time, as to not limit feed calves. Again, we need to really pay attention to stocking density. Okay, you can see clean, dry bedding. It needs to pass the knee test. Kneel down, and hopefully our knees are dry, and excellent ventilation. So those are going to be the keys to maximizing performance and limiting the challenges that we see with these systems. Okay, in other systems, we can have multiple nipples per pen, but again, we have to be real careful about crowding. And you can see in these pictures here, we may have some differences in the density of calves, and therefore could potentially pose some challenges. So let's move on to the acidified ad-lib systems. Again, I said they can be real basic systems, in other cases more sophisticated. People are feeding both milk replacer and whole milk. There are a number of companies now that have made a acidified milk replacer with citric acid or a variety of acid blends, so that all you do is mix the milk replacer as you normally would, and that's already acidified. And then the whole milk systems. And we see people that are that were in the past or continue to pasteurize the milk and then acidify, and then others that have decided to just acidify the whole milk without a heat pasteurization. And we can question here, there's not a lot of research, but to what extent do we have a chemical pasteurization? So we know that there aren't many organisms that grow at a pH of around 4.2, which is our goal to reach for pH. So are we successfully achieving a chemical pasteurization with our acid? Okay. One of the first questions that I asked early on, about 10 years ago, and I often preface my talks with this little story, but I had a producer that called me up one day after hearing Neil Anderson, who we can consider the father of ad-lib feeding in North America. Neil is from Canada, and he spoke at one of our producer meetings. And the next day, one of my clients called up and said, gee, we'd really like to try this ad-lib feeding. And at that point, which is quite interesting because now I spend quite a bit of time talking about this philosophy, but I said, gee, I don't think we really want to do this. one, calves really need to be raised individually. What about cross-contamination and disease issues? And did Mother Nature really intend for calves to drink a product that's a pH of 4? I mean, that doesn't seem natural. Well, I'm not sure if Mother Nature intended us to drink Coca-Cola either, but you can see from this graph, thanks to Neil Anderson, that the yogurt that hopefully we all eat daily to support our industry is about a pH of 4.2, which is our goal for pH for these ad-lib systems. And if you are drinking a Coca-Cola or Pepsi with your afternoon meal here, that the pH of that product is far lower. So I think we can argue that pH of 4.2 is probably okay for our calves if it's okay for you and I. So what are some of the benefits of acidification? And obviously from a feeding standpoint, we can preserve that milk and allow it to sit out at room temperature, or hopefully warmer, as I'll show you, to avoid spoilage. But over many years, there are other industries that have captured the benefits of acidification of mainly the water. So the poultry and swine industries have been using acidification as a way to control certain enteric diseases for many years. So this study from Turkey looked at the effects of feeding acidified milk replacer and growth and health of Holstein calves. And what they did is they fed calves traditionally, okay, twice a day feeding, but they had acidified and then non-acidified, or what they called sweet milk. And calves that were fed the acidified milk had increased feed efficiency and also had a reduced incidence of scours. And that's one thing that we notice in these systems, is that in most cases where there's good management and good hygiene, is that the incidence of scours is reduced to almost zero. And as most of you know, probably the most common disease we see in early calf raising situations is that of diarrhea scours. And we, for the most part, reduce this incidence to an insignificant level. So that's something that is directly related to the acidification of the milk. So what are some of the social aspects? This is where we get into some of the more touchy-feely aspect of the discussion, but animal well-being, animal welfare is obviously something that we need to be concerned about within our industry, and obviously our consumers are very concerned about. So I'll show you some other work that may point to the fact that social aspect encourages more intake, but this is just some time-lapse photography from one of my client herds where they have video cameras set up. And you can see here in this picture, the first calf goes over and to investigate or drink a bit. And over time, we kind of get this buffet line effect where, hey, that looks pretty good. We'll all go over and eat. So likely some social aspect to wanting to eat as a herd. Now, we still don't need a nipple per calf. This milk's available 24/7, but it does maybe bring up for discussion, do we need to have more than one nipple per pen? And I'd say yes, ideally we should. So I'll go on here to show you some of the aspects of these systems from a practical standpoint. And in real simplistic terms, these can be really simple systems. Some type of vessel for the acidified milk, a milk tube, one-way valve at the bottom, so this calf doesn't need to suck through the long straw every time it goes to drink. And then a nipple. We tend to use the peach teat nipples with a one-way valve in them. And then some method to keep that milk warm. And I'll go through these type systems. Okay. So one of the most common systems we have in place in a number of our dairies are these Rubbermaid, I call suburbanite trash containers. And you can see here, this is closed. They open up. We have a 55-gallon drum. The tubes can come off the drum. We drill some holes, as you can see in this top slide here in the side, for the nipples. And in this case, one box has 6 nipples, and it's placed so that this box can feed 2 pens at one time. So pretty simplistic system. Cost-wise here, with the heater you see here, the container, and so forth, under $300. So able to get set up with this type of system. Certainly try it out on your dairy for a fairly low investment. Okay. And then it's a bit of a picture show, but many different opportunities here. This is a seasonal setup for acidified whole milk, something that was put in place mainly to break the cycle of some disease challenges in this herd in the calf barn. So some super hutch protection from the elements, and a very simplified system here to manage the ad-lib feeding of milk. Just some trash barrels. They use a trash liner for ease of hygiene and cleaning, and then our lines and nipples. Certainly there have been, especially in the last few years, a number of facilities that have been built specifically for ad-lib housing and group housing and ad-lib feeding. And this is one such example here. And there are multiple different designs that are out there. And again, quite a bit of trial and error also. Within all these systems, though, we really want to size the facility for the dairy, being able to fill a pen within about a week, trying to keep that age range fairly close, and then also looking at the space requirements, not violating that necessity for plenty of space. There are a number of different systems around the countryside. This is a highline system where we have around the barn positive pressure line that then drops down through these boxes, prevent freezing in the winter, to feed nipples. And you can see on the right here, feeding these nipples through that positive pressure line. Other systems are more of a midline type setup. Okay, and these are the nipples here. We have each pen has 4 nipples that are fed off of these feeder lines that are at the at calf level versus a high line. This system can be put in place similar to the Rubbermaid boxes for routine feeding, or if we have some type of automated system, we need a way to wean these calves. Okay, so this is a box that we can offer these calves a known quantity of milk through the weaning process. One question that often comes up is how do we wean these calves? And that could be a challenge if you're used to traditional type systems. Remember, these calves are on full ad-lib feeding, so they're gaining most of their nutrient requirements, if not all, from milk. They eat very little starter. So, a good rule of thumb that we often talked about with traditional feeding is that let's start weaning when calves are eating 2 pounds or more of starter a day. Well, these calves are unlikely going to be eating 2 pounds of starter at traditional weaning ages. So we need to back down that milk so that these calves start to eat more on their own. And I'll say the longer we can do that, the longer period over which we can do that, we're going to have a smoother transition through weaning. So somewhere between 7 and 10 days, I think, is a good number. And there's also some research looking at weaning times that can support our practice of going out a bit longer, allowing these calves to steam up onto their dry feed intake before pulling all the milk. There's also more elaborate type systems for weaning here. Again, some of our producers are pretty handy with electronics, electrical systems, solenoid valves, and in this case we can actually set a weaning timer to deliver so many hours of milk per day so that we have a gradual weaning process over some period of time. So lots of different systems in place as we try to maximize the efficiency of using ad-lib feeding. So now I'd like to share with you some trials that we conducted here on our client dairies a few years ago to help answer some of the questions that often come about when we are implementing or recommending the ad-lib group feeding systems. So these trials were conducted in the late spring and summer of 2011. We had 3 collaborating dairy farms in Lewis and Jefferson counties of New York. And we had 2 main questions to ask. One was the group versus individual housing with ad-lib feeding. What are the effects of disease? Because many people would challenge that when we put calves in a group situation, we're going to cause more issues with calf disease, especially respiratory disease. Okay, so we looked at the performance of those calves in group versus individual housing with ad-lib feeding. We also then looked at citric versus formic acid as a preservative for milk replacer. And this is a good point to bring up why we did that. It's important for me to point out, if you are in the United States, that formic acid is not approved for the acidification of milk, okay, in calves. And this is important. Formic acid is approved for the acidification of livestock water. It is approved for the acidification of swine feeds. It is also approved as a chemical for the acidification of human foodstuffs. However, it is not specifically approved for the acidification of milk. So with that, we need to keep that in mind and have an individual discussion amongst your own management team and your consultants as to what type of product you'll be using on your own farm. So the first study looked at group versus individual housing. And in this situation, we had pasteurized formic acid acidified whole milk. It was fed ad-lib. And the group housing consisted of 8 calves per pen, each pen having 3 nipples. The individual housing was right next to the group housing, and I'll show you some pictures. We had clusters of 8 4x8 pens with solid sides, and each calf had their own nipple. So keep in mind that ad-lib feeding of the same product to all calves. The only difference here was calves that were either individually housed or housed in a pen of 8 calves. And you can see in the picture here, we had individual pens. So these calves each had access, ad-lib access to their own milk here through a nipple, and they had solid sides. Okay, and then here you can see right next to those calves and alternating throughout the barn, we had individual pens, group pens, individual pens, and they were again fed the same product throughout this trial. You can see here from the data that the average daily gain in the group versus the individual pens was significantly higher. Okay, and certainly this was a herd where we had just implemented group feeding, and you can look at those average daily gains of 1.5 pounds a day and say, gee, those aren't great, and I would agree. We consistently, in most of our herds now, are attaining 2 pounds or greater a day on these ad-lib systems. But certainly in this case, the group calves outperform the individual housed calves. This brings up a great point for discussion as to why, and really this is where we potentially see some social aspect. You know, why do these calves have a greater gain? The intake data that we had during this study was a bit difficult to follow through, given the validity of some of the recordings that we questioned. But certainly we are confident in the weight data, and we did see that difference. We also looked just to make sure that we didn't have any confounding effects by colostrum status and birth weight, and you can see here that at the start of the trial, the total protein and the birth weights were identical. We then looked at the effect of, or the incidence of disease in these cases, and fortunately for the herd, unfortunately for our research trial, this was a really well-managed farm with a low incidence of disease overall. So really difficult to draw any conclusion from this. You can see we had 1 case of pneumonia during the whole period. So total 40 calves in the individual housing, and we only had 1 case of pneumonia. So again, difficult to compare disease events. No scours at all. So at least in this farm, in this environment, we can say that there was no detrimental effect of group housing versus individual housing on the incidence of any diseases. Okay. So as I said, we do need to keep in mind the facilities. Okay, we certainly have seen some facilities where there's an increased rate or risk of respiratory disease, and those are often herds where we have facilities that haven't maximized or paid maybe as close attention to their ventilation needs. So I think in each case we need to work through these individually to troubleshoot what issues are going on and what we can do to improve the ventilation. Again, the other question that was asked during this time was, is there a difference in performance and growth between a citric versus formic acid preservative for the milk? And what we did here is we we had a custom mix of a 2417 citric, milk replacer that was made commercially, and that same milk replacer was also commercially acidified with citric acid. So identical milk replacer in terms of product composition, fat, protein, minerals, vitamins. One was acidified, one was not. And that was acidified to a pH of 4.2 with the citric acid, and also on farm, the milk replacer that was acidified with Formic was measured daily and acidified to a pH of 4.2. I'll point out here what's really important, and really is the crux of the results, is that there were some issues with the formulation, the second batch we received for about 2 weeks, and we had some higher pHs, and I'll explain that in a bit. This was conducted at 2 different facilities, okay, but both facilities had side-by-side comparisons going on at the same time, and had the same protocol for mixing and feeding of the milk replacer. Okay. This is an example or a picture from one of the facilities, and you can see here we just had alternating pens of Formic versus Citric, Formic versus Citric. So same facility, you can see the positive pressure ventilation tubes, and the only differences here were calves were allocated to either Citric or Formic. Okay. What is really important to recognize here is that during the feeding trial in one farm and then a second farm, the recordings of amount of milk replacer mixed, total solids of the product, and pH were done daily. But after about 2 weeks, the farm said, well, if we're mixing the same exact weight of milk replacer powder per water, and we've been getting the same total solids and the same pH day after day for 2 weeks, do we really need to continue to measure pH and total solids? This was a research trial, so the short answer is yes, we need to collect all that information. But they continue to do so on the product that was acidified on farm with the formic acid, because obviously that was the addition of an acid. But the commercial product, and maybe reasonably so in a commercial situation, decided to stop measuring pH. There was a second batch that was manufactured, and we still aren't sure as to what the exact reasons were, but we didn't find out for about a week and a half into the feeding of the second batch that the pH of that product was closer to a 5, essentially a 4.95. That was verified from samples that were also taken at the plant pre-bagging, and I'll have to clarify that this was really early on, prior to the availability of any commercial milk replacers that got pH down to that level. So it was a custom mix for us, special batch process. And since that time, both ourselves and the companies mixing this have put into place quality control measures that measure the pHs of these products prior to bagging, prior to shipping. So there are a lot of quality control things that have gone in place since this time. But essentially, we do know that mixing the same recipe with varying ingredients may not yield the same pH time after time. So what's important to consider here is that the issues that we saw during this this high pH feeding, okay? And I'll show you the disease incidence, but also look at the gains. And I want you to please take away from this that this is not related to citric acid, because actually the 2 of the dairies that were part of the study continue to feed a citric acid product. It's the pH that had a major effect. You could see the citric acid group had a significantly lower average daily gain than that on formic acid. Okay, 0.92 versus 1.14 pounds per day. Okay, and if you look at the disease incidence as compared to the other farm, and also as comparing the formic versus citric, we saw quite a significant increase in the amount of disease overall, but especially pneumonia and scours. Okay, so we have a almost 40% incidence of disease or death in the citric acid versus 13.8 in the formic. Given this information, though, the citric acid product performed very well, and we didn't see any disease events until about a week and a half or so, or a week into the feeding of the second batch. And at that point, we started doing some troubleshooting. We noted that the pH was very high in that product and corrected that immediately, and the disease incidence, the incidence of disease resolved rather dramatically. And again, these herds continue to feed a citric acid product today. So the point of this is that we do need to repeat this study to see if there are any potential differences between citric and formic on average daily gain when we know we can control that pH very tightly, which we obviously can. So subjectively, no apparent negative effects of citric acid. It's currently fed widely today in many cases in these commercial products. But that we do know that keeping the pH between that 4 and 4.2 range is very critical, okay? And likely the bacterial growth of that product that was sitting in the vats and or the direct effect of acidification that we see, the benefits of acidification were lost when we had a pH of about 5. Okay, so please the take-home point is that citric is not bad. It's a good product, but pH is important no matter what acid you're using to attain your pH level. Okay. So having gone through these systems, what are the advantages of ad-lib feeding? So access to feed, it's easy to deliver a high plane of nutrition. Can we start to approach a high plane of nutrition with twice a day or 3 times a day feeding? Perhaps we can, but I'll argue that, again, Mother Nature did not design a calf to slug feed a gallon or more of milk twice a day. We do know that we often, and not always, but often see increased incidence of abomasal bloat, clostridial diseases when we feed large quantities of milk twice a day or 3 times a day. What ad-lib allows us to do is deliver that same volume or greater volume of milk over a 24-hour period, so more natural to suckling. There are some labor efficiency to be found. Again, we need to be careful. We're not saying to put a vat in with some nipples and don't come back to visit the calves for 48 hours. But we're not washing pails, washing bottles and nipples. We can spend more time with the calves directly. But most herds do realize some decrease in labor on the more monotonous tasks of cleaning and hygiene. We don't really know the full benefits of socialization, but the group in British Columbia does a lot of work in this area of well-being and socialization, and I think over time we'll see some more work, research that points to the benefits of that. Certainly a huge potential for increased growth rates. We're feeding ad-lib milk, and potential for improved lifetime productivity. So remember those first few slides that I showed showing the overall benefits of feeding for a higher level of nutrition. What are some of the disadvantages? Again, there's always some challenges. Disease transmission can be a challenge, but again, I think in well-designed facilities, whether that they be new or retrofit, we can overcome these disease issues. Okay, and it is a change in management style. Okay, so change brings potentially some challenges. So we need to reset how we find a sick calf. When you walk into an ad-lib barn, these calves don't jump up and start bellowing because they are satisfied. Okay, they're not paying attention to the person as the source of feed. It's available all the time. So how do we find the sick calf? How do we manage these systems, so forth? It's a change, but again, we can effectively get through those things. What are some of the economics that's often argued here? We won't spend a lot of time. This is some work that Mike Overton did and presented at the Western States meeting in Nevada, and I'm sorry, Reno. And you can see here, if you look through the benefits, the costs for these conventional versus intensive system here. Okay, so the total rearing costs are going to be increased, but we have additional milk. We have production in that first lactation is going to offset that so that we actually have an additional profit for the intensive rearing, despite us having an overall increase in the cost of that initially. Okay, so how do we acidify? Try to show you a few things here as we start to get to the end of our presentation here. Remember, formic acid is a concentrated acid, and it can be dangerous, so it must be diluted before use if you choose to use it, and you need to have be cognizant and discuss the approval within the United States. Okay. Neil Anderson has done a great job on his website. If you you Google Neil Anderson feeding nature's way, there'll be lots of great documents there. But essentially, we're diluting the 85% citric acid down 1 part of acid to 9 parts of water. We're going to want to measure pH with a pH meter or pH strips or sticks, okay, tight range sticks. But generally, we're adding about 30 mils of this dilute acid to a liter of milk or milk replacer. The art of getting the milk acidified can be a bit of a challenge at first, and we do know that we need to have aggressive agitation. We need to have cool milk. If the milk is warm, we will make cheese reliably, and we want to add that acid slow. Okay, and the combination of these three is going to determine how we can effectively acidify our milk without making a cheese again. Okay. Again, our goal for pH is somewhere in that 4 to 4.2 range. Use a tight range pH paper or pH strips, which are available, or a digital pH meter. Okay, and you want to keep in mind that feeding much below 4 or above that 4.3, 4.5 range may affect palatability and/or bacterial growth. Again, aggressive agitation, that can be through pumps, that can be through circulators or agitators. This is a really simplistic method here of just a paint stir on a cordless drill. That works quite well to achieve that agitation. I'm going to recommend that we feed milk that's at a higher temperature than some others may recommend. My preference is for 90 degrees or higher, okay, at least 75 degrees, so that means that even in the summer months under warm conditions, we know it cools down at night, especially this time of year yet, we need to have some type of supplemental heat, okay, so that's important to keep in mind. These are examples of some band heaters that are available online that can be set to maintain the temperature. They work really well for both metal and plastic drums. More likely we're going to be seeing plastic drums in use. And then perhaps we also need some type of supplemental heat to prevent lines from freezing in the winter in colder climates. Okay, and these are just some of the things that we need to use for these systems: the peach teat nipples, one-way valves, some tubing, and the band heater, which works really well to keep our milk at a warm feeding temperature. Just an example again of one of these Rubbermaid boxes, both here and here. Pretty easy to design, pretty easy to use and fill. And here's a calf enjoying an ad-lib meal. What about inner sucking? Question that's often asked. In excuse me, in most cases, if we are truly feeding ad-lib, these calves are satisfied. They have access to the nipples. They have access to ad-lib feeding, and they're not real interested in sucking each other. Okay, and this just, you know, there are options. We don't want to see these in every calf, these weaning rings, but sometimes you get a calf that likes to suck her neighbor a little more, and there are some options for that. I'm just going to quickly go through some keys to success from our experiences here, and then we'll wrap up and have some time for questions. So again, mostly a review: stocking density, at least 30 square feet, 3 square meters for those of you in other countries, of lying area per calf, and dry bedding. Can't stress that dry enough. And excellent ventilation. Remember to maximize air exchanges per hour depending on the environmental temperature, and work with some of your consultants to get this into place. Don't just buy a plastic tube and a fan, because you will not get it right. True ad-lib, let's not limit intakes, okay? I don't think we know as well as Mother Nature, let the calves drink. Try to fill a pen in about 7 to 10 days. There are herds that do wider ranges quite successfully, and again, as with anything, it's multi-factor. Depending on the availability of milk, nipples, square foot, you can have greater age range, but that 7 to 10 days of age works quite well. Keep in mind that cold milk really discourages intakes, and also in the winter or any time of year, that calf needs to warm that milk back up to body temperature after it's ingested, and that takes energy. So why don't we offer milk closer to body temperature, 85, 90 plus degrees, okay? That's going to really encourage intakes, especially in younger calves and during cold times of the year. As I showed from the citric versus formic acid study, pH is really important. Keep that range within that 4 to 4.2. Maintain consistent total solids. Brix refractometers are easy to use. They're inexpensive. you need to, whether it's milk replacer or whole milk, keep track of what your Brix readings are, okay? We're feeding dry matter as we feed to our cows. We need to keep track of our total solids. You're going to have to use, bring the milk down to a temperature below 75 to acidify, and therefore have a way to warm it back up. So these are some of the logistics, but they can be done. There are lots of people doing it. And then again, just concentrated acids is dangerous. We have the approval concerns within the U.S., but be careful. So with that, don't want to take up the question time, but any questions or comments for discussion here? Be happy to entertain any discussion.
Well, at this time, Mark, we'll turn the program back to Steve. If you want to give us our next slide, please, Steve, you can kind of walk us through the next two slides, if you would, please.
Okay, very good. Well, first of all, Mark, thank you very much for a very interesting presentation. Well done. I'm always impressed by the innovation of dairy farmers and their advisors to come up with systems and equipment to meet a challenge. It's quite interesting. And also, regarding today's webinar, I want to thank the Dairy Calf and Heifer Association, which helped us make this possible today, and mention that their annual conference is coming up next April, 1st, 2nd, and 3rd of April 2014 in Green Bay, Wisconsin, and so you might want to keep that set of dates in mind. Also, as some of you or many of you who have been with us before know that all of these archives, or all of these webinars rather, are available on the archives, going to hoards.com and clicking on the webinar section, and this webinar itself will be up in a couple of days, and all of the past webinars are available there. So far, we've had about 23,000 archive webinar views over the last 2.5 years. A pretty impressive number. Also, those of you that were with us today will receive an email including a very brief survey, which we'd like to have you respond to help us make sure that our webinars meet your needs and your interests in the future. Coming up next month, July 8th, Mike Hutchins will be our presenter, and he'll be talking on the subject of playing the crop year cards we've been dealt. That is going to be sponsored by Lilleman, and there are a variety of crop conditions around this year. So, Mike, that'll be a very interesting presentation. And just looking a little bit further ahead, Larry Trinnell from Iowa State University will be talking about experiences with robotic systems. That's going to be sponsored by DeLaval VMS. And I think we do have a few questions for Mark. So, Mike, I'll let you address those, and we still have quite a lot of people online with us. So, back to you, Mike.
Very good. Well, Steve, thanks much. Again, Dr. Mark Thomas, my thanks to you for taking time out of your busy schedule also to present this very interesting webinar and the various technologies that are out there. We do have some questions, so hang on to your hats, and here we go. One question had to do with that milk production in the first lactation that you showed on your budget. Would you expect to see that in second and third lactations as well, that increased milk production that reported in your summary slide?
That's a great question, Mike. And yes, the research, a number of studies have followed those animals out to second lactation, and the benefits have been seen in both first and second lactation. And then we can't say they're not captured in third, but that information is more difficult to obtain given some obviously culling within that period. But certainly, yes, that is a difference that's seen first and second lactation, not statistical in the third lactation.
There are two related questions here, Mark. The first one, and they both have to do with starter intake and your comments about Ad-lib intake. When milk solids are going to be pricing around $1.50 a pound and calf starter at 20 cents a pound, can we not get some benefits from getting calves on starter sooner? Thoughts on that versus Ad-lib on liquid?
That's a great question, and one that we need to answer here. I'm really looking at the feed efficiency question, and we hope to have some information regarding that in the near future. But what I will present and just say, and again, this is perhaps more opinion, but the opinion of others in the industry also who have a lot of experience and knowledge in early calf nutrition, is that within the first 45 days at least, and maybe 60, but you say at least 45 days, that that these calves should be based on their digestive systems and so forth, are best suited to consume liquid feed in the form of milk. And then you can argue as to what extent do we have room in development prior to 45 days, and to what extent we should be pushing that solid feed. So great question, an area where we need to have more research, and hopefully we'll have some in the near future. But I feel that if we're starting the weaning process around 42 days or so, 45 days, that these calves are best suited to consume a liquid feed almost exclusively prior to that time. Then certainly, as quickly as possible, getting them onto solid feed, yes. Again, that's a bit more of opinion, with hopefully some research available in the near future.
Another question from Italy, actually, and his comment was, we see a lot of tubing, meters of tubing. What about the hygiene and cleanliness of that tubing that goes from the milk to the nipple?
That's an excellent question, and we really see a variation in the amount of cleaning that gets done in these systems, from almost nothing, and I'm not saying I recommend that, to a fairly extensive cleaning. Given that these systems are pretty much a continuous flow system, and we have a pH of the product around 4.2, we see very little, if any, bacterial growth in these systems. So I was intrigued a number of years ago. I had the opportunity to visit a very large cream cheese manufacturing facility, and that facility is shut down once a week for cleaning. Otherwise, it's a continuous flow system. Obviously, lots of serial bacterial cultures and analyses being performed throughout the system, but the theory or process that takes place there is that if we have pasteurized product going into the system and there's no bacterial contamination, it's moving through. And I'll say we see the same in our systems here. I do recommend some cleaning on a few times a week or so, mainly to remove any solids that have accumulated in the barrels or in the lines. But what most people are doing is no appreciable cleaning of the lines nor nipples between groups of calves, but at weaning, discarding the tubing and the nipples as really disposable items, and then putting in all new installation with a new group of calves.
Okay, another Italian question, even broader. He says, when it's very hot, will there be any problems with the acidified ad libitum system, or have you seen any differences between summer feeding and winter feeding using the acidified ad-lib system, Dr. Thomas?
No, I haven't. As I said, in order to acidify milk without creating a cheese or cottage cheese, you need to have that milk below 75 degrees, slow addition of acid, good agitation. However, once the milk is acidified, you can easily bring it back up to 100 degrees. I don't think we've had many producers push that above 100 degrees, but you won't cause the formation of cheese as long as it's already diluted out and through that product. So probably the one comment I'll make is that oftentimes, though, in the summer months, people start to think, well, it's warm out, I don't need supplemental heat to keep my milk warm. Just the other day here, we've had some warm days but cool nights, and without supplemental heat, that milk temperature is about 60 degrees. So keep in mind we need some supplemental heat year-round. The difference being in some of the outside systems, if you fill them twice a day and that milk going in is warm, then it tends to maintain that heat within a 12-hour period. So grab a thermometer, grab a Brix refractometer, grab some pH paper. It's quick and easy and inexpensive to monitor these things, so keep track of them.
Another question just came in and wanted to know about holding that pH in warm weather. Have you done any checking to see, if with the acidified citric milk product holding that 4 to 4.2, does it change after 24 hours or 12 hours or 8 hours, depending on how long it's been in the barrel?
We've done quite a bit of that, Mike, and we haven't seen any appreciable change. We've looked at total solids, we've looked at bacterial counts, and pH. You will occasionally, most herds are mixing this once a day or every other day, so that's going to be the majority of our experience. You will see some Enterococcus bacteria growth. That's an acid-loving bacteria, and that bacteria is non-pathogenic and will tend to lower the pH more because it's producing a lactic acid, but not to any appreciable extent. But again, I think, like I said, monitoring temperature, pH, solids, mixing throughout the day. If you don't have some type of automated agitation, this milk needs to be mixed throughout the day a number of times to prevent settling. So these are all areas where, work with some of your consultants or some of the information that's available online to manage this.
Dr. Thomas, when you were looking at your reviewing literature, did you see any other organic acids like malic acid or maybe lactic acid or something like that instead of the two that you mentioned?
So a number of the milk replacer companies that are acidifying the products will have some what they call proprietary blends of acid, so a combination of citric, propionic, and others. We're in the process of looking into some other acids at this time. Some limited experience with malic acid, and we say at this point to probably stay away from that as an acid in terms of palatability and intakes. But certainly there's area in these to look at the different opportunities. The downside is that something like formic acid is not produced by just one company, so there's very limited impetus to have someone go through the research and approval process as if it was a proprietary product that was available from one company. So those are some of the issues we deal with. As I said, the individual on-farm decisions, not necessarily recommending it, but formic acid is approved in Canada. It's approved for other livestock uses. So I think beyond that, it's your decision as to what product you use.
Well, Mark, we have time for one more question. This is a pretty interesting one, I think. Your opinion. Cool acidified milk works well when we have overcrowding in different calves' ages. It seems to stop the aggressive calf and leaves place for the younger ones to consume the less aggressive one. Do you agree with that? And then the next part of the question is, what about water consumption in an ad-lib system?
That's a great question. I will argue that if we have any case where we see any competition for milk, then for some reason that milk is not being delivered ad lib. So there's either not milk available 24/7, there's some plugging of the lines, there are not enough nipples, and the comment was made that they were overcrowded. So my argument would be, let's reduce the overcrowding if we can, because our goal is to maximize intake. So sure, we could feed cooler milk, and maybe they don't drink as much, but then that is counterintuitive to our goal of maximizing intakes. So I would say let's try to ease that overcrowding or do something so that we can maximize our intakes and then feed the warm milk. One of the arguments that's often been made is that cool milk limits slug feeding. And I always use the example, if Mike and I were sitting at the China buffet all day, and they brought out a new dish, we might mosey on over and try that new dish and have a few pieces, but we probably wouldn't run up and get that new dish because we've been eating all day. So likewise, is a calf going to stand up and go to the milk bar and slug feed when it's had access to milk 24/7? I don't think so. So, or I can say I know so because when we refill that vat, the calves don't pay attention to that. They have access all the time. So let's try to do what we can to maximize intake. I think, Mike, was there a second part of that question?
Yeah, that second part, by the way, I won't comment on the buffet thing at this time, Mark. About
okay.
What about free choice water?
Unless it was a piece of cherry pie or something.
What about water? What about water consumption in an ad-lib system? Have you monitored that at all, or what's your experiences?
So that's a great question also. So we provide free choice starter from the first few days of life, as in most feeding situations, and free choice water. Free choice water will be a bit dependent on time of year. We do see increased intakes in the summer months, but the only time where we see variation in that significantly is if total solids aren't being mixed correctly towards the high side. So we see increased, actually some increased intersucking behavior and water consumption when individuals will either incorrectly or purposely try to increase those total solids, I'll say much above 15, 16%. But free choice water availability, I think, is important in all cases.
Well, Dr. Mark Thomas, thank you very much for your commitment. I'm going to turn the program back to Steve to wrap up at this point.
Well, again, thank you, Mike. Thank you, Mark, for a great presentation, very interesting. And it was good to have you with us. Thank you, Mike, for being your great co-host as usual, and Jim Baltz, your technical sidekick down there who makes this all possible. And we also, of course, thank the listeners, the participants today. There's still quite a number of you out there showing your interest in this subject. We thank you for your interest and participation today, and invite you to join us again for future webinars on July 18 and August 12, second Monday of each month. So we look forward to seeing you then, and thank you and goodbye to everyone.
Great. Thank you for joining today. It's been a pleasure.